When we use function notation and we want to do operations on different functions, such as addition, subtraction, multiplication, and division, we have a shortcut way of writing those things. So instead of writing out long f of x plus g of x, meaning take equation f of x and add equation g of x to it, what we can do is shortcut it and say f plus g of x. It functions the same way. It just means add the two things together, but it's a quicker way of writing things. And mathematicians are often very big fans of writing things slightly faster. So let's start by looking at what this first example is talking about. So we have an f of x squared minus 4 and a g of x squared plus 3x minus 10. And they want us to find f minus g of negative 3. Well, what does that mean? It means find f of negative 3 and subtract g of negative 3, because f minus g of x means f of x minus g of x, and in this case our x is negative 3. So all we need to do is kind of come over here on the side and say, well, what is f of negative 3? If I plug a negative 3 into this equation, what do I get? Oh, I get 5. And if I plug negative 3 into the x's of the g equation, what do I get? Well, I get negative 10. Well, if f of negative 3 is 5 and g of negative 3 is negative 10, then when we subtract the 2, minus a negative is positive, f minus g of negative 3 is 15. It's that easy when we have numbers. What would this problem be? F dot g. What does dot usually mean? It usually means times. So what are we wanting to do here? It's saying take f of negative 3 and multiply it by g of negative 3. Well, f of negative 3, we said that was 5. G of negative 3, we said that was negative 10. So f times g of negative 3 is negative 50. It is that simple. Now, that's when we had a number plugged into this equation. What about this second version here? We have the same equations, but instead of a number like negative 3, we just have an x. So what this means is they want an answer that looks like an equation or looks like something like that. So we still want to take f of x and we want to subtract g of x. Now, the one hint I will say here is you want to put things in parentheses when you plug these in. So what is f of x? F of x is x squared minus 4. And what is g of x? G of x is x squared plus 3x minus 10. And do you see how, especially with that second one, I put that negative sign there? Why did I do that? Because if I'm subtracting this whole equation, I need to subtract all three of these things. So I need to distribute the negative. If I don't put the parentheses there and I just write it like this, the only thing I'm subtracting is that first term of x squared. I'm not subtracting all three terms. So when you are doing these problems and you're plugging equations into other equations, put things in parentheses so that we do the operations correctly. So we're going to start by distributing that negative so that we're subtracting all of the things of that second equation, and notice when we subtract a negative it becomes a positive, and then we're going to collect like terms. So x squared minus x squared is 0. We get negative 3x plus 6, and there's our final answer. Let's try it with the second one. F dot g, what does that mean? It means take the first one, notice it's in parentheses, and we're going to multiply it by the second one. Okay, how do we multiply a binomial times a trinomial? Remember, we multiply the first part of the binomial times all three things. So we're going to get x to the fourth plus 3x cubed minus 10x squared. And then we multiply the second term of the first times all of the terms of the second. So we're going to get minus 4x squared minus 12x plus 40. We collect these two little like terms here, and we get x to the fourth plus 3x cubed minus 14x squared minus 12x plus 40. Final answer. Now, Let's look at our last one here, f over g. This looks like a fraction. Yeah, this one is actually a pretty straightforward one. This is a division. We're just going to put our f of x on the top and our g of x on the bottom. So in this case, that will be x squared minus 4, and we're going to put it over x squared plus 3x minus 10. It's tempting to stop here on this one, but anytime you have quadratics and you feel like you're done, I want you to be suspicious and be like, can I factor that? I feel like I should be able to factor that. And you actually can. Remember the difference of squareds? This is going to factor 2x plus 2x minus 2 because 2 squared is 4. And the bottom, two numbers that multiply to negative 10, well, that's 5 and negative 2. So we're going to have, x plus 2, x minus 2, not x squared. So x plus 2, x minus 2. And on the top, we're going to have x plus 5 and x minus 2. So why would I have needed to go ahead and factor this? What do you see is going to happen? Well, look, we have x minus 2 divided by x minus 2. That's a 1. Those things cancel each other out. And our final answer here is x plus 2 over x. Oop, there's no x here. Goodness, y'all, I'm on a roll. X plus 5. Final answer.